Okay, I think I can be heard. I'm gonna turn up the volume a bit more and I'm going to quit the demo. Hello! So let's switch back to the stream here. Okay, so welcome to the Flux Engine build stream. The thing that you just watched was a demo. If you don't know about the demo scene, a couple of times every year coders, artists and musicians get together and program stuff for old and new hardware, and basically it's self-running code with nice graphical effects, nice music. And this one was called Memento Mori by the Genesis project. That's what the team is called. And they started off 30 years ago or something in my hometown, Aachen. But by now they are a very international group and I'm not sure if there's any members still in Aachen. But yeah, they won the Function 2020 demo competition with this piece for the C64. I just played it in the Vice emulator because ripping apart my C64 setup here so that I can stream was not the best idea probably. But anyway, today we want to do something, and you can see me, but you don't see a live picture of my phone for some reason. And I'm not sure why, so I will have to detach my phone and reattach, and hopefully we will get, yeah, this looks better. Yes, my hand is visible. All right, yeah, so what do we want to build? We want to build a Flux engine, and the question is, what is a Flux engine? I'm gonna push my setup over a little bit so that you can see more of the green thingy. The Flux engine is a very cheap USB floppy disk interface capable of reading and writing exotic non-PC floppy disk formats. That's from the website. Long story short, you can take an arbitrary PC floppy drive like this here. This is just a very bog standard 3¼ inch floppy drive, but you can also take one of the big floppy drives, the 5¼ inch, and you can read Amiga disks, you can read C64 disks, you can of course read PC disks, you can read Apple II disks, and basically any format. And they do this by using the drive as a playback or recording machine. Just because it records magnetically, it will just take the flux information, that's why it's called the Flux engine, and it will be output here over the pin header. And then the digital to analog converter on the SoC on this board here will sample that and just record the flux straight to a file, and then you can interpret the encoding later. The problem with disks, with floppy disks, is that, for example, the Amiga uses a non-standard encoding with varying speeds on each track. The C64 is similar. And if you want to make images of that, or if you want to write a new disk from a disk image that you downloaded, you have to use either complicated stuff or use a GoTech floppy emulator or something. Or if you want to archive old disks which are failing, you usually can't do that if there's a bad sector, but with this you can still read out everything that's possible and try to correct errors later. So that's actually pretty neat. And there is one very famous device like this, the CryoFlux it's called. It's a commercial product, but it's actually rather expensive. I think it's around 100 or 150 euros. And that is actually not very cheap, I would say. But this year, I already got this one here. This is the Greaseweazle, which is a very similar device. Also using a little ARM SoC. And yeah, it works fine. It costs around 10 euros. The software is still in development, so there are some drawbacks due to the software. but it can do a lot of stuff, and it's very nice and cheap. So the Flux Engine uses a slightly different board. This is also less than 14 euros, I think, so 10 to 14 euros, also pretty cheap. By Cypress Semiconductor, it's the CY8CKIT-059 PSoC, and this very specific one actually. There are numerous variants. You can get this at Mauser for, I think, 13, 14 euros, something around that. And it's a very nice development board, even if you want to do something else, want to do ARM SoC development. That's pretty nice. So this is basically an ARM processor down here that has lots of inputs and outputs, general purpose, I2C, digital analog converters, I don't know. All kinds of stuff. So that's pretty nice. We will need some pin headers, solder that to that. We will need the floppy cable, of course. And I will put the Greaseweazle aside. So with the Greaseweazle I have a 2-row pin header because I have this adapter board. We don't have that here, but we only need 1 row plus the ground pin. So we will need to check where the ground pin is on that and which way it will end up on here. But first of all, we just need to unpack this and solder pin header 17 pins because this is 34 pins. So I think I'm gonna open this because I didn't yet. Okay, it says here peel away. And here it is. There's even, that goes into the trash. There's even a little bit of Captain tape on here. So I'm gonna try, let me see where my hands are. Okay, so I'm gonna get a bit closer. So this thing consists of 2 parts. The left part here is the USB interface, and I said don't disturb, but it doesn't matter. So this is the USB serial interface. Basically this part goes into your computer for programming the device. There's basically just a USB to serial interface, and then there's the serial interface. You can even break this apart and solder a ribbon cable in between. Then we have a, I guess this is a reset button or something, the actual SoC, and a USB, micro USB socket, which interfaces to the PC later when it's actually used as a device for reading the floppy. And we will solder a pin header, I think, somewhere up here. And yeah, that will be more or less it. So it's not like a big project for solder-wise. Anything else in here? No. So there's what's nice is you've got the pins all named here, which is pretty neat. But I have no clue. These are general purpose, I guess. There's I2C on there. Crystal out, crystal in for external clock, I guess. Yeah, that should be fine. The ground pin is important because we need to, and down here as well, so there's a ground that we need to put on the floppy drive connector as well, because the floppy drive will be powered by my retro PC's what do you call it, power supply. Yeah, and let me try and show you. Oh, I should probably put away the stream. Will begin shortly because it has already begun. Here's the Flux Engine website, and we should take a look on how to build this thing, making a Flux Engine. Come on. Okay. So what do we need? We need 1 or more floppy disk drives. Check. We've got that here. We've got the development board. We've got a pin strip. That's what we have in here. And a floppy drive cable. We have a power supply in the retro PC. We have a Windows machine, actually in here. It's a virtual machine with the PSoC programmer by Cypress. That is the program that we need to put the Flux Engine firmware in, and then it will program the device. And I think I should probably turn on the webcam and turn off the audio jingle. I think you might have heard an echo or something. So if anyone's in the chat, tell me if the audio is okay now, because there might have been some weird echo from the feedback. Yeah. Anywho, so we need basic soldering ability. Hi Karopi, welcome. You didn't miss much. We haven't really started now. We're just going through what we need to do. Optional, some kind of box to put in. Yeah, not today. We won't put it into any thing. So here's, it actually goes on the bottom side. Here we can see what it should look like. So we leave VDD IO and ground empty, and then we put 17 pins in there. And later we also need to look up where the ground pin is. It's probably on the up row, and then we need to tie it to ground here. That should be possible, I think. Doesn't sound too bad. Let's quickly switch back to the desk view. Okay. So here we got very nice machined pin headers. Let's check them out. Let's count to 17. 2, 4, 6, 8, 10, 12, 14, 16, 17. Count again. 2, 4, 6, 8, 10, 12, 14, 16, 17. Yes. Let's cut it here. Let's turn on the iron. So the most interesting part will be to see if this whole thing actually works, if the software side works, because the soldering will probably be done quite quickly. So I'm gonna put it up here so that you can maybe see something. I'm gonna take more light over here, so there you should be able to see it. Okay, let's get some solder. And put this down here. So I left open VDD IO and ground. Trying to get one pin down. Yes. And on the other side I'm gonna take one pin down too. Which does it take? Yes, it takes. Okay, so if something is wrong with the audio or something, you please tell me. Jonas Karavas, hi, welcome to the stream. We just started soldering, and in the first couple of minutes I explained what the Flux Engine is for. Basically it's to create disk images from old floppy disks, or to write to old floppy disk formats. That's also possible. So both directions are usually possible. Many people will just use it for archiving their childhood floppies, or I had a colleague who wanted to archive his father's data, basically. But for retro gaming or whatever, yeah, glad I read your name correctly. I had a colleague called Jonas. So I hope I didn't butcher. And I mean, German is from pronunciation probably closer to Greek than to English, I would say. I'm gonna not talk for just a minute because actually I have to put a lot of heat onto that, and I have to take a close look. And when I put away my Johannes, yeah, I think it's Johannes. But he was actually also Greek, so he was called Johannes. So I'm not super happy because for some reason this doesn't take the solder quite as I'm used to. Jonas says, so you can connect any floppy drive on that and it will allow you to read any kind of floppy disk. Color me interested. Yeah, not any kind of floppy drive, basically any kind of floppy drive with the 34 pin connector that the PC uses. 3.25 inch, 3.5 inch, and 5.25 inch with the edge connector. Those are possible. For others, you might have to rewire, I think, but PC drives work best, and you can basically read almost any kind of disk. There's a caveat, an interesting caveat, especially for C64 disks, which is the same problem with the Greaseweazle, which is another of these devices. The only difference here is the software mainly. The SoCs are slightly different, of course, but yeah. So C64 drives have a problem. Oh, let's leave that on. It was a bit too early. C64 drives have a different. Let's put that to standby. C64 drives have multiple differences. So they are single-sided. So you have to turn the disk, and let me fetch the disk. So here I have a C64 disk, and it is single-sided. So if I put it in, the read head is on the bottom, so it will read from this side and write. And if you want to use both sides, you have to punch a hole in here with a device like this. This is a hole punch for making holes into the disk, because if you want to write to the disk, there needs to be a notch here. This notch needs to be open. So then I can turn around the disk and put it this way into the 1541 drive from the 664 and write to that side. The PC drive has two read heads, so it can read both sides at the same time, basically. Goes up and down, but has a different problem. So the read heads of the PC are not in sync, but they are offset by 4 tracks. So I can read the bottom side, side A, just fine, which is great, but the top side I can't read the first 4 tracks, which is a shame. So you could say, okay, then just flip it around and read just one side, which would be okay, except all the drives, like the PC drive, except for the 1541 from the C64, use this hole here, which when I turn it, we'll see there is a hole in the floppy disk. Not sure if you can make it out, but I'm gonna put it up here and you can see there's a hole in there. This is the index hole. Every time it goes around, there will be a light pulse going through, and the computer will know, okay, this was 1 revolution. The C64 doesn't do that. It just spins the disk constantly and synchronizes with the magnetic data. A PC drive, when I turn it around, will not see the pulse because the hole is on the wrong side. It will not read because it doesn't get the index pulse. There are hardware modifications. You can either punch a hole in the disk, which is destructive, we don't do that, or you basically just attach a tiny magnet, tiny magnet, onto the flywheel of the PC drive, and a small Hall sensor which senses when one revolution is complete, basically just by the magnetic impulse, which is fine. So you need a very small hardware modification. Basically, there are some other ways you can jumper some disk drives, some PC disk drives that they work without the index pulse, but then the software also has to ignore the index pulse. So, except for this complication of things, you can read almost any floppy disk. And also write, of course. So, what we need to do now is, we need to figure out where on this, because this is the floppy disk cable for the PC, and we're gonna walk through this as well. This is a common floppy disk cable from, many years back. It has 3 connectors, but the PC, standard PC, can only use 2 floppy disks. There's ways to do more, but the simplest interface is only 2 disks. This goes on the PC side onto the floppy disk controller. This here is for 5 1/4 inch, so the big disk drive, which uses the edge connector. This here as well, and this here is for the 3 1/2 inch disk drive. The twist here is to select drive A. The PC was very inventive. Usually you have, does it also have this? This one doesn't, but 5 1/4 inch drives usually have jumpers where you select drive 0 and drive 1, that is drive A and drive B in the PC. But the PC didn't want to use that. They just wanted to slam in the disk drives and not care about jumpering. So what they did is to make a twist in the cable, and that actually selects drive A or drive B, which is a clever hack in some ways, but also annoying in some others. So with this cable I can use, because I want to try today to get reading out one side of a C64 disk, we can use drive A being 5 1/4 inch. I have different cables as well if we want to use drive A of one of these. But yeah, so we need to figure out where on this end. So it will go probably like this on here, maybe maybe the other way around. We need to figure out what way it needs to be. And let's have a look at the web page again. Let me switch back to OBS, and here we are. So let's go back to how to build this. So we've done this, and this looks good. Yes, this is exactly what we did. And the question is, where do we need to? Yeah, it says about that. Stupid enough, it doesn't say what the pinout is, so we need to Google that real quick. Gonna quickly PC floppy drive pinout, something like that. That should be good. Seems I already visited that site. Okay, here it explains again the cable. Do we have an image? Because I want to know where. So pin 1 is on the side where the red stripe is. The question is, am I facing up or down? Probably we get a picture somewhere here. Oh, this looks better. This is the best website for pinouts on the internet, or almost the best. So, do we get a picture? I want to have this picture. Why doesn't it show that? Okay, here we are. So at the moment we got the female connector on this thing. Okay, so there's a notch on the top. There's a notch on the top here, and to the left of it is pin 1, which is good. Interesting. And ground, where do we have ground? It doesn't say right away, does it? Does anyone see ground? I see density select, index motor enable, drive select, floppy write enable. So this already explains that I probably need to put it like this. So looking at this picture, there's the notch. So this here is pin 1. And we are basically using the bottom row. So we are only using pins 2. So all the even pins, basically. We are using all the even pins, which makes sense because they are the ones that have stuff on them here. But it doesn't say what pin ground is on, which is probably... Does it have ground? Maybe it doesn't have ground. That would be weird. Then I need to tap into the Molex connector. I wouldn't like that. So if anyone with Google Foo has some time, maybe you can look up which pin that might be. That's the same. Power connector. Power connector has ground. Yes, we know that. Can I tap onto ground somewhere? That would be super. Rotox says ground is on every odd pin. Shall we trust Rotox? Shall we basically... Oh, look, here. Floppy drive port, internal. So, no, not on every odd. If I took pin 3, that would have been bad. That would have been a good short. 13 to 27 is basically ground, which is quite a bunch. So if I put the middle pin, take the middle pin, it should be fine, I guess. So let's get some cable from over here. Big box of cables. Yeah, let's just take this one. The question is, this is for a Tandy. Tandy might have something slightly different. I mean, it looks mostly like that, so maybe double check. This is Roland. No, I don't want Roland. I want a PC floppy interface. I just want to make sure that we have ground. Floppy drive interface cable. So it says here everything's ground. Well, is it? I'm not sure. Can't we get some... So can anyone... So Rotox, I guess you took it probably from this picture here or a similar one. But I'm wondering... FM Towns. The problem is there are so many interfaces. But I just want to know... which one here has really, because I don't want to connect to +5 like on the on the Tandy, it seems to be that the first couple of pins are +5, which would be devastating, to say the least. Question is, can I simply beep this one out? So if I have a look, on my drive here, I can see that pins 1, 2, 3 and 1, 2 and 3, no, 1, 3 and 5 seem to be not connected to the ground plane, but all the others are. Yeah, I think this is a pretty safe thing. So I'm gonna show you that. Just use the multimeter on the drive itself. Yeah, exactly. I think that's what we should do. I'm gonna show you. Take away the beer. So have a look at this. So up here are pins 1, let's shift it a bit, 1, 3 and 5. I can see that there's like a gap, like a dark gap. You can see it too in this slide. And then all the others seem to be connected to this big green ground plane. So I'm gonna beep this out to the ground pin on the Molex connector. To make sure. So we are in continuity mode. We're in continuity mode, and I'm gonna put my probe here on the middle, which should be ground. Yeah, pin 1 is not connected. Pin 3 is not connected. Pin 5 is not connected. Pin 7, 9, 11, 13, 15, 17. Yeah, it's basically the upper row except for the first 3 is ground. So I can just take one of the middle pins, which is okay. That way we should be certain that we don't blow anything, at least. Okay, time to try that. So I'm gonna take this cable, which should more or less fit just nicely in here. Yes, it does. And I'm just going to solder it directly, maybe. Yeah, I'm gonna solder it directly, otherwise I'm gonna lose it. I can replace it with a pin at some point. Just have to be careful not to melt the pin, hopefully. Yikes. That's not nice. It wasn't my best attempt at soldering. Okay, this looks better. This seems to be sticking. So we can do basically the following. We can put this in. Pin 2 is at the left, and then we can basically plug it into, smack into the middle. So now we should have a nice ground connection. So this is our crazy thing. Next up, we need to flash the firmware. So I'm gonna take this out once more. What do we need? We need the Windows desktop. We need a cable. Do we need that? Yeah, I'm gonna use a cable. Or I'm just gonna plug it in like that, maybe. Question is, I'm going to use a cable because there I can see which way it's facing. So this is basically just an extension cord for a USB socket. So at the end there's a USB connector, yeah, USB edge connector, that's right. You probably missed the beginning. So once more, to take a look, this is the piece that we put into the PC, and there's a serial interface on there, and you can break it apart and put a ribbon cable there. I'm not gonna do it, I'm just gonna plug it in with the extension cord. So you can flash the SoC, which is here, and then we have the actual USB port that you can use for proper USB communication when you are doing, so this goes to the PC when we're doing the reading or writing, and it will register as some serial interface, I guess. Yeah, but this is just fine, I think. We should be able to plug it in like this. So now I've got it in here, hopefully sturdy enough, and I'm gonna have to run the cable somehow. Excuse me. So it's blinking, that's a good thing. It's not shorting out yet. And now we're gonna switch to the PC here, to the virtual PC, and we need to forward this one, the Cypress semiconductor. Let's see if that works. We fire up the, okay, I heard a sound, so it definitely registered setting up a device. Okay, this can take a couple of seconds, I guess. This is what the programmer looks like. I should probably go to full screen. Yeah. I should probably go to full screen. So now we're gonna program that device. Let me get the mouse over here. So did it see anything? It already loaded the Flux Engine, it seems, because I tried loading that before, and the device is ready. Okay, that's good. And that did work. Port selection. Okay. How does it work? Checksum, read to log, erase all flash, patch image. Load from hex, load from device. What is this black in the corner? Nobody knows. It says voltage, which is fine. Protocol, I don't care. How do I program? Utilities, upgrade firmware. I'm not sure if that is needed. Read to log, I don't want that. So this is already loaded. Question is... Okay, this did a checksum on the PSOC, which is empty, and with my file, which doesn't equal, which is good. The question is, does it mean patch file? Patching starting. Oh, they call it patching, not programming. Okay, or flashing or something. Patching is the name. So it's blinking furiously. Blinking very furiously, and I mean, looks good. What are your bets if this works or not? I think at the moment it looks pretty okay. We'll just have to figure out how the Flux Engine software works. I used the Flux Engine software for the Greaseweazle, not for reading and writing, but for converting between different formats, because Greaseweazle doesn't support very many formats, And Flux Engine actually has pretty good format support for different disk image types, etc. Oh, okay, there's a progress bar down here. I didn't see that because my mic is in the way. But this looks good. Patch succeeded. Doing checksum. Match blocks, distinct blocks, something, something. Patching succeeded. Let's do the checksum test once more. And the checksum of the PSOC and the hex are the same. I think we have some kind of Flux Engine, which is nice. What we will need now is something. I'm gonna unplug this. Do I need to eject it or something safely? I'm not sure. Is there anything? It doesn't show up, so I'm just gonna take it off. Disconnect it, it says. Yeah, I think that's okay. I'm also gonna shut down Windows because hopefully we don't need it right now anymore. Update and shutdown, yeah, do that if you must. And we're gonna switch to the Flux Engine software. And I'm gonna turn up the volume on the terminal so that you can see some stuff. I already checked out the Git version of Flux Engine. Should be the newest. I'm up to date, I think. And now I'm gonna attach the Flux Engine. Let me quickly show what I'm doing. So let's put away the mouse. I'm now gonna take the other USB cable, and this time we don't use the edge connector, but we use the one with the Captain tape on it. And I will have to remove it. And I guess they put that on there so that people don't start and try to program it via this end, because that won't work, I guess. So people have to peel it off. And we are first gonna try and use the 5 1/4 inch because that should work. We can actually try to image this disk here. I mean, it's nothing special on there, but we can try to image Zeta Wing, which is a nice new shoot 'em up game from this year for the C64. And I'm gonna put in the ground pin again. I'm gonna put in here, which way? This way. The USB. And first things first, I'm gonna try and plug this in and not detach the iPhone cable. Oh, let's hope this is long enough. We will see. So, it is alive. It is saying blue, and we will eventually have to put this down where the PC is. Let's see how far I can get. Yes, this will barely reach over there. That'll be okay. We will switch back to the terminal now because there's not much to see. I'm gonna open up the retro PC. And at this point, to make it clear, the retro PC is only needed due to its power supply. The drive and the power supply, but you can put the drive on the table, it doesn't matter. You just need a power supply for the disk drive. You can also use a lab power supply or something else that provides 5 and 12 volts. Especially for the 5 1/4 inch drives, you need the 5 and 12. Some of the 3 1/4 inch can run on 5 volts only, I think, especially if it's a newer one. But I think most drives will take 5 and 12 volts. Okay. Quickly open up the PC, unplugging the 5 1/4 inch, and now we will do something very dangerous by letting this dangle, and we will, yeah, okay. So it's hanging in midair, so that's always a good thing. I'm gonna turn on the PC so we have power. Looking good. So nothing happened. It beeped, so it's complaining because it's not finding the big drive anymore, which is fine. It just needs to provide power. I'm putting in the floppy disk. And now we need to figure out how Flux Engine works. So, slightly going over here. And I need to switch to, not to OBS, but to the terminal. Here we are. I'm gonna open another sub window here. So, how does it work? Oh, sorry. So, if I call Flux Engine just like this, reads the disk producing a sector image. That sounds reasonable. We're gonna have a look at my scripts that I wrote for the Greaseweazle, because here I already had some scripts, especially for the C64. So this is a script for the C64 which uses both the Greaseweazle software and the Flux Engine. And let me just show this. It will call the Greaseweazle software to read in double step mode, because there's another interesting thing. I have a high density disk drive in there. That means 1.2 megabyte disks. They have 80 tracks or cylinders. The C64 uses a double density disk drive which has 40 cylinders or tracks. So I need to move the head not once but twice to get to the next track. Otherwise I read tracks twice, and that wouldn't make sense. It also, to make up for read errors, it will read 5 complete revolutions, so 5 index pulses. So you can average out errors, which is nice. You can also do like 50 if you have very valuable data where you know that the disk is bad, and to read and read again until it works, or maybe scrapes off the magnetic coating, depending on the thing. The end cylinder is 39, which is 40 tracks. And I also read single-sided. So we need to find out the way how to do this in Flux Engine. And the output will be named something SCP. SCP is the Supercard Pro format. The Supercard Pro was basically one of the very first of these devices, which could produce Flux-based images. And then we use the Flux Engine to convert the SCP to the Flux Engine native format, because if you have it in the native format, you can actually produce D64 images. So this is my pipeline currently to image a C64 disk. I hope to make this simpler, to skip on this part and just have one command for reading with the Flux Engine. And the Flux Engine is supposedly software-wise a bit more flexible. But Greaseweazle will for sure catch up at some point. The Greaseweazle is actually made by the same guy that also does the flash floppy firmware for the Gotek drive. His name is Kier something. He's KierF on GitHub. So he is definitely a very good coder, and he knows his way around floppy disks. So his software will eventually get better and up to par. I think Flux Engine is just around for longer. So I just want to try it out and see how it works, and it's a very good alternative, I guess. So what we want to do is probably do the read, right? Ha, what a pun. Let's do read help. Okay, doesn't work. Read help. Okay. Let's try read C64, maybe? But what are the... Ah, look at this. Okay, there's a lot of stuff. We don't want to change the revolutions at the moment. It will, by default, it will read 2 revolutions, and this is a good new disk, so that should be enough. Sync with index false, whether to wait for an index pulse. That is actually good. That could mean that we could even read the second side by flipping the disk. That would be neat, with more revolutions probably, because most of the time you will start in the middle of one revolution, and that's of course not a good thing. And source. Okay, this will just take the first drive, which is fine. And we just need to do this, because the output will be called c64.d64. Let's try it. That doesn't look good. It didn't throw any error. Did it blink or anything? I didn't really look. So let's do this again. No, it just there's just a blue light, and what a blue light is doing you all know probably. Okay, so that didn't work, but it also didn't throw an error. Let's just try the following. Let's detach. I just detached it, and if I do it now, it should say error. Okay, it says no USB devices found. Is one plugged in? Do you have permission to access? Which is good. So that means plugging it in actually makes it visible and accessible to the Flux engine. Oh no, I hope I didn't destroy anything. Turn off everything. The connector just fell off, which is not optimal, to say the least. So I probably need to put some tape on there. I do have Captain tape somewhere, and I'm gonna use non-safe standard Scotch tape. Crap. Yeah, this is not good. I need to do something about this. So sorry for being probably a bit quiet. The pin header that I used is definitely not good. The precision drill sockets are good for like all kinds of stuff, but not for this. They are a bit too narrow. And let's face it, the main problem is that I have this hanging in the air. So I'm just gonna take this over here and put it onto something, and I'm gonna put something heavy on there just to hold it down. So once more. Okay, the PC is beeping. Let's try again reading. But I don't hear anything from the drive. What we can do is the following. We can try the... There's multiple settings, of course, that we can try. I don't hear the drive starting, which means that it could be that the drive select is wrong. You'd find it easier to do the initial test with the 3.5-inch drive. Yeah, we could try the 3.5-inch drive. Then I need a different cable actually, or I need to put in a different device number, because we can use here a different drive thingy, right? Let's use, just for testing purposes, use drive 1. Oh, sorry, that was wrong. So that's -s. Now I hear something. Look at this. It was drive 1 because whatever. Tuck, 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 tuck. And you see it's in double step mode. It reads only the even tracks. This is actually looking good. This is actually looking pretty good. We're gonna open this directory. And it opens, of course, on the wrong desktop. We're gonna fire up the emulator, which also opens up on the wrong desktop. And I want to get back to your... this is flickering like mad. And we're gonna drop the image in. It was called C64D64. What do you think, guys and gals? Will it run? It's loading. It's loading, it's loading. Will it work? Let's get those loading bars, those uncompression bars. It of course loads as slowly as an original 1541. There's the loading bars. That looks amazing. This will be very good, I think. And here we have Soldering. it's amazing. It works. Can we actually play? I can play, but I don't know where the joystick is. So I'm gonna die, but yeah. Yeah, I think that's cool. So that's it for the stream. No, just kidding. We should probably also try the small drive, the 3.5-inch drive, and put some Amiga disk in there, right? Just for testing. So let's do that. Let's shut down the PC. Let's disconnect the. So. One thing definitely, put something else in there. I'm gonna have to order a proper connector from Mouser and have to desolder that one, because those machined things are terrible. They just slip out at the slightest touch. Let me quickly fetch a disk. There's the disk. And I'm now gonna try and attach the 3.5-inch disk drive very quickly. So it goes in like this. Okay, so this is good. But this time I have the untwisted thing, so let's see if we have to use a different drive select then. So we are gonna check for the Amiga. And we're gonna use the standard source. Just try it like this. Oh, it works. Okay, it can't read that for some reason. Bad checksum. Okay, I've taken maybe a nasty disk. Okay, I'm gonna Yeah, okay. So I just popped out the disk and it definitely works. So here it says, okay, it says bad checksum. So this is a demo, so it could be like a weird disk format. Let's take something more easy. Let's just take Workbench. Maybe Workbench works. No. That's interesting. It always says bad checksum, which is interesting. So Amiga disks seem to be kind of a problem. Question is why? Question is why? If anyone has any ideas, that would be interesting to know. I mean, I'm already pretty happy that it does work, and this time it's also reading something, but the question is, why does it say bad checksum? So what do we have here? So we can set the device, which is fine, the default, the revolutions is fine, sync with read, sync with index is false. Index mode, index pulse source drive, 300 RPM fake source, 360 RPM fake source, this is actually, the index mode is actually nice if we could try to read the second side of the C64 disk. Maybe that is something we could try with a fake 300 RPM source. Read failure shouldn't be, because these are so I have two new, basically these are, I'm gonna hold it into the webcam here, these are new Maxell disks, which I use on the Amiga without any problem, so that should be fine. But I think there's something wrong here with the decoding or something. It can just dump undecoded records. We can try that maybe. Let's tell it to dump records or something. Oh, look, there was something before I broke it off. Oh, wow. Okay, we see something. So that is the dump something, I guess. Yeah, I'm not quite sure why that is happening. Let's check maybe the documentation. could be useful information. Sorry, I'm a bit lost. I don't find here. So, what does the documentation say? Otherwise, we will just try and read the second side of the C64, which would be immensely useful, because that's something I can't do with the Greaseweazle at the moment without modding my drive. So, building the hardware is probably not what I want to look for. So here's Amiga. Let's take a look at Amiga. So it says just to do Flux Engine read Amiga, which doesn't work. Let's see. Amiga disks use MFM but don't use IBM scheme. Instead, the entire track is read and written as a unit, with each sector butting up against the previous one. This saves a lot of space, which allows the Amiga not to just store 880 kilobytes, but also allows an extra 16 bytes of metadata per sector. Well, it doesn't say much about this. So there's not much info here. I'm gonna give it one more try, maybe, but I'm not sure what to specify here. We can try. I mean, we can try to just output the flux, just like this, maybe. But it doesn't really help, does it? Could be that these tracks are empty, but that doesn't actually make much sense. Or I don't think that the problem is that we have a high density drive, because if I remember correctly, I could read Amiga disks very easily with the Greaseweazle, so I would assume that the Flux Engine can do that. I hear the stepper motor, so that's working, and if I pop out the disk, it also stops working. It says doesn't work. Let's just get it to run through. Maybe there are bad checksums and it just writes the data anyway. I'm not sure. And maybe we get a broken disk image, maybe not. This will take a while. So I would say this is a partial success at the moment. I need to figure out how to do this Amiga stuff. It is definitely working, and it is a pretty cheap solution. As I said, you can check out the Mouser website. I can show you. Mouser. And I just threw the thing away here. So let's have a look. We are looking for the... it's still in my search here. So here you have it. This is the kit, and it's 1271 excluding tax. So with tax it's a bit more. And of course you need to get to, at least in Germany, you need to get to 50 euros to get free delivery. So you need to pool with someone else or pool with a different project. But then I think it's actually a pretty cheap and nice solution. We would need to figure out if Amiga disks are possible or not, but it should be, right? So probably I'm doing something wrong, I would guess. Yeah, they have like hundreds still, and they expect new shipment. So if you want to do your own thing, then yeah, this is the way to go. And the alternative is the Greaseweazle, which I showed at the beginning. And the Greaseweazle has two different models, the F1 model, which I have, and the F7 model, which is a bit better and supports two drives at once. This one only supports drive 0 or drive A, basically. And this is what the different versions look like. This is the F7, this is the F1. And you can find it on github.com/kirf/greaseweazle and the CryoFlux on cowlark.com/Flux Engine. So both are definitely worth checking out if you want to be able to read and write old floppy disks. Here's the setup again for the Greaseweazle. And you can even power your drive from the Greaseweazle board, but again, that will not work on 5¼ inch drives. And as it says here, 3.5 inch drives typically require only 5 volts power. But if you want to do like the C64 images, then you will need definitely an external power supply for that. But both are pretty cheap. And the other one that I talked about, the CryoFlux, that is more or less a commercial product. It looks like this. It already has the Molex header on board, which is nice. It also has the standard PC 34-pin connector and this older one for, I don't know, Apple II, something else, I don't know. For older stuff, definitely. And there should be some place by, and this is, I think, the German web store. Yes. And what does it cost? What is it? Yeah, 140 euros. Oh, look at that, we get something. We get useful tracks. I was just too impatient, it seems. Let's see if the image works at the end. Rotax says it can read Amiga floppies for sure. When the project first started, I tested it with the disk I've had since the late 80s, early 90s. Yeah, I was already thinking that I probably did a mistake. It's usually, the problem is usually not the hardware, but the user. So let's fire up UAE and see if the image will work. Because I think the light went off. Here's the FSUAE launcher, and we have something. We had 23% bad sectors, which could mean that those were just empty, or I don't know, some way. I should check my Kickstart ROM, because I think this demo will not work without a proper Kickstart. So there we have it, and we will put in the floppy disk, and that should be in my folder for the Flux Engine, right? Here we have it, and there's Amiga ADF. Okay, I'm taking all bets if it will work or not. Just pressing the start button. This is normal, but that doesn't look promising. No, I think it doesn't work. Too bad. So it kind of worked. Is it my floppy drive, maybe? So 23% good bad sectors wasn't good enough, I think, and there was 1% missing sectors for some reason. But there is data, as you can see here, right? But not good enough that we can actually decode a full image, it seems, which is a bit sad. So that doesn't work. Yeah, this is an open question. What we could try before getting this stream to a close is, I would say we try the B side of the C64 image, because that's something that I couldn't do with the Greaseweazle. So let's take a look again, and we need to rewire our setup. So unplug everything. Oh, it's actually getting even a little bit warm. So everything is plugged in again. I put in the, now I will flip over the disk. The PC is beeping. I flipped over the disk, and let's go back to the C64 side. We needed to use drive 1, and we will also need to use index mode 1, which is a fake 300 RPM source, because C64 disks rotate at 300 RPMs. I'm not sure which ones do 360, if it's the 3.5 inch discs. I don't know. But let's see if that works, or if we need to use the 360 RPM fake source. No idea. Let's also ramp up the revolutions, because I'm not sure what happens. Revolutions set to, let's say, 5. Okay, it's doing something, but it can't decode anything. Maybe we need to use the other fake source. Or the disk is complaining because it doesn't see the index pulse. Not sure. This will probably not work. No data. Yeah, I would say this won't work. But let's have it finished. Then we get a nice empty disk image. Probably. Perhaps. Yeah, there's basically nothing. Let's try the other fake source. No. So that doesn't work. Not sure what the fake source implies, if we need to actually have something on the drive, but for me fake source is like, yeah, no, we just pretend there is one in software. Let's check the documentation here for the C64. Very slim documentation. It just says what a drive. No, that doesn't make sense. So that doesn't seem to work, and it doesn't say much in the way of the documentation, which is a bit sad. That was my hope, that it's actually better at doing that. So that doesn't help. And if I remove the index mode, it shouldn't work at all, I would say. Yeah. That's like a machine gun. Because why does it happen? The drive isn't sending any index pulse anymore, and if I skip the index mode parameter, then it wants to use the index pulse from the drive. If there is none, it just skips ahead, right? So there's nothing to be decoded. So I think one of the other index modes would have been useful. However, they all deliver 0 bytes, and there is something on the other side. I know that because I had it running on the C64. So yeah, it's a bit of a disappointment. I was hoping that this is an easy solution for getting the second side of a C64 disk image. So definitely, if we are down to this and it doesn't work like that, then we can actually also use the Greaseweazle and just mod one of the drives. So the Greaseweazle at the moment, as I said, has a bit of a problem outputting to something else than the SCP format. The Flux Engine I use not only for the C64, but I also put a script here for reading Amiga disk, for example. That did work just fine for converting the Greaseweazle SCP output to an ADF. So at the moment, I would say, for me personally, the Greaseweazle works better, and not sure why the Amiga disk on the Flux Engine produced so many errors in the beginning, because I think that broke the image. I think, as Rotok says, it probably works, but there's some problem in my setup, I guess, that I haven't figured out yet, which is a bit sad. Do we have something we can use? We can try to read an IBM disk. That would also be nice, because a lot of you people will have old IBM PC disks, but probably not an old PC. So if you get a drive and can image your old data, then that's also nice. Let's do the test with the Interplay Lord of the Rings game. This was the first game that I bought from my own money, and I imaged the disc the other day with the Greaseweazle, so I know that it works. And let's try to do that here as well. So Flux Engine read help, and we're gonna image an IBM. So IBM -- help. Okay, there's a lot of different options. The question is, okay, we will switch the source. Actually, we will do the same format as for the C64, because we need to switch again to drive ID 1 and side. Oh, sorry, what is the sides? 0 and 1. We want to read both sides, and we want to go track 0 to 79 with double step, because this is also a double density disk. This should lead to a readable image of the first disk of the Lord of the Rings. Let's check that. That's looking good. There's a lot of bytes being decoded. And it's also very quick, as you can see. So one nice thing, I have a 1541 actually sitting here on top of the retro PC, attached with a serial to parallel cable to the PC. And I can write disk images using the old DOS PC, but it's slow. It's very, very slow. So I would love to be able to write stuff fast to a C64 disk. And as you can see, it takes like half a minute or something. Let's open up again this thing here. And we have the IBM image. And we should be able to just open it using macOS. Maybe. Where did it go? Did it end up somewhere where I didn't look? Oh yes, it did. Here, on the other screen. Let's look inside. But it's already looking good. Yeah, here we are. We successfully imaged an old MS-DOS disk. And there's the executable and the setup. We could even run this in DOSBox now, but it's only one of the disks, one of the 5 disks, so that wouldn't be very useful. But we could, for example, open this with TextEdit, I think. Let's open this with TextEdit and see. Yeah, there's the batch file for the installation. So that does work. That leaves my problems with the C64 side B and with the Amiga disks. And as it stands, the Greaseweazle, with the help of the Flux Engine software, is for me more useful at the moment. Maybe in the future I will be able to figure out a way to get this fake index running. I will put a question probably to the author of the software if he has some hints. And maybe I will also get the Amiga disks working, because that would also be nice. But as it stands as of now, I must say the tiny little Greaseweazle here works a little bit better. But I'm still missing the chance to write the second side of a C64 disk, or read the second side. It doesn't matter. Both ways should be possible without modding my drive, that is. Because modding such an old drive is always entailing some risks. You have to solder something onto the board. So yeah, that is not optimal, of course. But yeah, I think both options are probably worth exploring, and yeah, both are very cheap, especially compared to the CryoFlux, and the software is pretty okay and pretty good. And you have to know that it's still not like a complete plug-and-play solution. You will have to solder a bit yourself or assemble some stuff yourself. But I mean, if you have some valuable data, some old games, or something that your parents or you yourself in your youth programmed, wrote, or I don't know what, then definitely check out these nice little gadgets. I mean, if it's very important data, then you can probably shell out the $150 for a CryoFlux. But I think it's nice to have these open source solutions, because it shows you only need a tiny ARM processor with a digital to analog converter and the other way around, to actually read and write directly to any disk format. And that's already very impressive, I think. Yeah, but in the future I probably more use the Greaseweazle until I get the issues with the Flux engine sorted out. I think that's more or less it for the stream. Thank you all for dropping by. We didn't image any new demo that I could run, but I will put something on the screen while seeing you out. Definitely make sure to subscribe to the channel. That would be very nice and useful. And leave a comment on this video or the other videos. Jonas says, it feels like a Raspberry Pi should be able to do something similar, although overkill. Yeah, the good thing about these microcontrollers is that they don't run an operating system. And the Raspberry Pi would have to be more or less real-time capable. That is, the program that does the reading and writing must not be interrupted, or else you will have gaps and stuff. So using such a small microcontroller is actually, I think, better suited to this task. But that being said, and also the Raspberry Pi doesn't have an ADC or DAC on board. So that would also be a problem. You would need a special head for the Raspberry Pi, and when it comes down to that, that's already way too much and too expensive. But what you could do, of course, is make a little head for the Raspberry Pi with an STM32 or the Cypress PSoC, and put that on top of that, and that just runs the Flux engine or the Greaseweazle firmware, skipping the USB interface and using the GPIO or some other means. That would be possible if that's fast enough, actually, because USB is fast enough to pull all the data to the host PC. But you could probably use the Pi as a host for one of these devices, that's for sure. But I think it would not be a wise choice for doing the actual reading and writing and interfacing with the disk. And one more thing, if you have lots of these disks and want to use it all the time, you need also some nice enclosure with a power supply. And people use external SCSI cases for that, but they go for quite a lot of money. If you look on eBay, they can sometimes be around €100 just for one of the empty cases. I don't know why, but they are either very rare by now, or people still see a lot of value in them. So yeah, that's another thing to keep in mind. But you would probably put something into an enclosure only if you have like hundreds of disks that you need to archive, or if you have like a small software shop where you sell software for old machines. Then you probably want to have something like that to reliably and quickly produce new disks, basically. Yeah, but again, make sure to subscribe and check back on my regular videos, and also all the other stuff that I produce. And very nice to have you all here. I hope this was insightful to some of you, and you now know if you want to do one of these interface thingies yourself. I think it's very useful to have as an option, and we should check out some demo, I would say, for closing off the stream. And I'm just thinking where I put all my demos, and probably not here. but somewhere here. Yes, there we should have something. And I'm gonna pick Edge of Disgrace because that's a wonderful C64 demo, and I already fired up this one. So thank you again for stopping by, and hope to see you next time. I'm gonna turn down my mic now, but please stay in the chat, leave some comments, and yeah, see you soon.
you